Oh, here we have a project entitled Controlling Devices Remotely at Distant Areas Without Manually Switching, which is being submitted for the NI Yantra 2011 competition. The team includes Ashok, Kashyap, Harish and Anvesha, and our mentor is Professor Sanjeev Reddy, Associate Professor BBRIT, and Rohan Sood, Application Engineer NI. The project is implemented using National Instruments WSN. Firstly, we have NI PS15 power supply which delivers voltages between 24 to 28 volts to the Ethernet gateway controller. Here the gateway used is 9792 Ethernet gateway, which is connected to the computer using a Ethernet crossover cable. Then we make use of NIWSN 3202 measurement node, which accepts inputs and delivers outputs in the range of 9 to 30 volts. It has 4 analog inputs and 4 digital I/O channels. In order to change the device state and analyze the state, we use the relay circuit. It consists of step-down transformer delivering 12 volts to a bridge rectifier whose output is around 6 volts. The inverter circuits of the inputs of the relay drive separate devices, each of which is connected to the unique DIO port. Moving on to the programming part, first we need to configure the WSN nodes using Measurement and Automation Explorer, which can be opened. In order to configure the gateway and the nodes, we use the MAX. When the controller is connected via Ethernet crossover cable, the NIWSN software detects the same under the remote systems, which can be seen here. NI9792 Ethernet gateway is being detected. On expanding this NIWSN 9792 gateway, we have devices and interfaces. Under this devices and interfaces, we have a WSN. On clicking it, we have NI measurement nodes detected. Here we have added NIWSN 3202 measurement node, which is a voltage measurement node, and NIWSN 3212, which is a thermocouple measurement node. However, the project requires the use of only voltage measurement node. This completes the configuration of the NIWSN hardware. Moving on to the VI. The VI of the project was completed beforehand. The same can be seen on the screen. On double clicking the project Explorer window gets popped up onto the screen. On expanding the nodes of Ethernet gateway, we get the nodes attached to connected to the gateway. Here we have connected the 3202 voltage measurement node to the node 2. On expanding the node 2, it displays all the inputs and outputs and the other ports available to the node 2. On opening the project, a front panel gets displayed as shown in the desktop. On opening the window, show block diagram. A block diagram window gets popped up. Here, on dragging and dropping the inputs from the Project Explorer window onto the block diagram, which can be seen as shown in the block diagram. Here we create an indicator which indicates the state of the device. And here the input from the measurement node is given to the less than logic, which is compared to the 1, which is a result of offset voltages generated, which is given to the Boolean LED, which glows when the supply is when the input to the measurement node is less than 1 volt, which this LED, when the Boolean LED glows, it indicates that the device is on. The same can be implemented for the other devices. We have implemented the device 2 using the same process, using the analog input 1. In the same way, we have a digital I/O port. Here we have energized all the digital I/O, 4 digital I/O ports using the port 17 of the measurement node 3202. Here, which consists of switches arranged inside the measurement node. On switching the digital I/O port 0, closes the switch in the digital I/O port 0, and digital I/O port 2, on closing the switch 2, the digital I/O port closes and the device gets connected. On running the program, the code gets deployed onto the hardware, which can be closed. On switching the digital I/O port 0, here we can see that the analog input 0 is 6 volts. Here that is a result of inverter circuit. As the device is off, we have which is given to the inverter circuit. So the resultant output voltage is 6 volts. In the same way, for the device 2, when we switch, here the Boolean LEDs are arranged, which indicates the current status of the devices. Here the LEDs are off, which indicates that the devices are off. On switching the digital I/O switches, the corresponding LED in the VI glows and the device gets on. On switching the device 2, the device 2 gets on, which can be seen in the front panel with the respective Boolean indicators. Here we can see that the analog input gets 0 as the device is on. In the same way, we can switch off the devices by just clicking on the device 2. The device 2 gets off and device 1 gets off. This concludes the project. Thank you.